In this video, we'll start working on our game. It will be a simple tower defense game with one map, a tower in the middle, and a character which defends it from monsters that spawn randomly. Maybe we'll expand it in the future, but for now it is quite small. First of all, we need to create a project. Click the New Project button, give it a name. Let's name it Tower Defense, and open it. This is the main interface. To the left is a section with project elements, which will contain all our code, assets, folders, and whatever. Everything will go in this section. You can close it if you want with this arrow button and return it. You can also close it with a middle click, and most of the elements in the editor can be closed with middle click. The main area, this one, is where our editor will go. One of the editors, since this engine has a code editor, a world editor, model editor, and many others. Some of them will be opened here, some of them will be in separate windows, but that's a topic for another day. In the bottom left, there is already familiar menu button, video options, which we'll talk about when we get to world editing or model editing. An offline indicator, which is used to indicate internet connection when in collaborative mode. The run button, which compiles and launches the current application, and a menu in which you can select what kind of build you want to make. For example, you can make a DLL or an executable or whatever. You can also open in Visual Studio or save as an Esenthel project or export the project into something else. You can see that you can export it as a Visual Studio project. And in Esenthel engine, you can write code either in the editor or in some external IDE. If you start the project in the editor, you can then switch to an IDE by exporting the project. But if you start in an IDE, you cannot go into the editor and bring the code here. So it is one way, and I recommend starting in the editor, since it gives you access to all the features of the engine. But if you'd like to use an external IDE, you can check the external IDE section of documentation, and you'll find a step-by-step guide there. Now, getting back to our project elements, you can see that there is already a green folder named Titan Engine. It is what is called a library element. You can create another one like this by using your right-click here and see the library. And it is basically a folder that is useful when you have several applications in the project and they all use some common code. For example, all the applications here will use the engine API, so all of it is in this library. You can hover over code files to preview them, and over most files to preview them. And you can open them with one left click. When a file is opened, you can see it adds a tab with this file to the top. And to close it, you can either middle click on the tab, or in the red here is selected the current open file. You can click on it again, and it is closed. Notice that you cannot close the folder in which you currently have an open file. So you should either switch to another file to close it or close that open file to close the folder. To make our game, we'll need what's called an application. It is an element that's compiled into whatever we chose here. In our case, it will be an executable. If you hover over the application here, you can see some more details, but we'll just create it and call it, I don't know, game. If you have only one application, it will be build and run automatically when you press this button. But if you have several, so let's create another one, you will get checkboxes near the application and you'll have to select which one to run. Let's remove it. When we remove elements, we sometimes want to restore them. And to do this, just click this bin button at the top, and you'll see the grayed out application that we just deleted. You can right click on it and restore it if you'd like. But I'll keep it removed. If you double click on the application, you can see a lot of settings, which will be useful when publishing it. And you can also include some headers or libraries in case you'd like to use some external libraries. We won't need this for now. Now we'd like to create a code file. So we right click on the application to create the code file inside this application and create code. let's call it main. You can also drag most elements onto one another and outside one another to rearrange them. For example, here I dragged the main code outside the application, here I returned it back. And for example, if I make another code, I can drag it inside this code to create some hierarchy. It doesn't actually change how the code is executed, it's just for organization. So it could be useful if you'd like to keep your project more organized. And you could notice something strange. Engine uses C++ as its scripting language, but there are no headers and CPP files. Everything is just one file. Code is just one text file where you can type things. This is specific only to the editor. If you use an external IDE, you will still get your headers and source files separately. What's going on here is that the editor changes a bit how C++ works. So headers are generated automatically during compilation, which means that you don't need to include anything. All the code which you write in any code file is available in any other code file, which can be really convenient at times, but means that namespaces are really important if you don't want your project to be really cluttered. Other changes to C++ include no need for double colon or arrow operator, since you can just use dot operator everywhere. The size for basic data types is also defined. There is no need for U prefix between UTF-16 strings. Super keyword can be used anywhere to reference the base class from the derived one, and some others. You can find it all in the documentation. And there are also a lot of macros defined in the engine, which you can also find there. Now that we have our code file, let's make a minimal application. We could type it all by hand, but we could also notice that in the bottom we got some new menus. The file menu has options to save, close, or locate file in the project. For example, if you have 1,000 files, it will take you to where this one, the one that is open, is located. The view mode is something we'll look at in a minute. And the edit menu has a lot of stuff for editing text, including insert template, which has empty application template, which we will use. And it pastes here very minimal application, which is what we need. An application has several global functions, for example, init pre, which is a function which is called before initialization of the application and is used for setting up some engine settings. The init function, which is used for loading data. The shut function, which is called when an application is closed. All these three functions are called only once. An update function and a draw function are called each time the game updates. For example, with 60 FPS, they're called 60 times per second. Now let's see what's already included in these functions. Let's say it's my first time opening this engine and I have no idea what all this means. For example, what is d.clearCall? It is some function, but I have no idea what it does. There are several things that can help us understand the code in Esenthel editor. First thing is the familiar Ctrl F, which opens a Pine window, and here we can type this, for example, clear call. And here we can see it is in function, some display class, clear call, and here are two overloads of this function. Let's go to any of them. And it took us to the Titan editor display API. And we see here this function and a nice comment that says what it does. To quickly return back to the previous location, we can just click right mouse button and we are back. Another way to do this is to use the view mode we saw earlier. Here you can select what exactly you want to see when you use it. I'll leave it as it is. And I enable it. Now, if I hover over anything, I see its documentation to the right, which can be really convenient if you'd like to quickly see what does what. And another way to quickly go to a definition of something is to use a middle mouse click. For example, the same clear color, I click on it with my mouse wheel, and I'm here at the definition. And it works not only with the engine-defined stuff, but also with custom classes, functions, and whatever. So let's make another one. I make a test class, and I leave a comment that this is for testing. I'll leave it empty. And then we see that we don't need to include anything. We can already, for example, in the init function, test class created, and we can use the same middle click to go here. And Ctrl F works the same way with user-defined classes. What you could notice is that when I tapped it out, it doesn't only show the name, but also some information here, for example, type, definition, full name, and comment. So this comment for testing that I left here is shown in the autocomplete here. So you can very easily document your own stuff to not get lost in your own projects. Returning to this code, let's finish with what is already here. For example, this init function, I go there. I see that it loads some information for the engine. App.flag sets some flags for the window. For example, it should have a minimize button and a maximize, and it should be resizable. If we go to these flags, we can see there are a lot of them, and we can set any of them in the init pre function. The init does nothing, shut does nothing, update checks if the user pressed keyboard button. BP stands for button press. We can see it if we go to here. BP if key pushed in this frame, so it's for one press. And it returns false. When an update function, a global update function returns false, it means that the app should no longer exist, and it closes, calling the share function, and so on. Here we see it updates the GUI. What is GUI? It is main GUI. We'll talk about it later. For now, we can delete whatever is connected to GUI here, because it won't be relevant for now. And in the draw, we call this clear color, which just clears the screen with nothing. By default, it is set to 0000. So now, just to see that it works, let's make it print some stuff, and we'll output it not on the screen, but in a console. So I'd like to know how to log stuff. I use Ctrl F and start typing log. I see here is some log function. So I go there. I want to log strings. I don't want the mathematical log, the strings. And here we see there are several options for logging. You can log into file, you can set what exactly you want to log. But for now, we want the simplest, let's say log n, which logs with a new line. But we can also see that we need to set log console to true, which will open the console itself. Without it, the log won't have anywhere to type. So in the init pre, we can use log console true, and in update, let's say we use log test and new line. And let's run it. And we see that it runs fine, printing a lot of test strings.